Hello again. Today we are going to discuss our next topic of digital logic design and continue to our topic with combination logic circuit. The next topic is to design half subtractor as well as a full subtractor. As we seen in the previous video, we have designed half adder and full adder. As we all know that in arithmetic operation, the subtraction task is a very important to perform different subtraction operation. So the subtraction consists of four possible elementary operation, namely zero minus zero equals to zero, digital 0 minus 1 is equals to 1 with 1 borrow, 1 minus 0 equals to 1 and 1 minus 1 equals to 1. In all operation, each subtracand bit is subtracted from the minuend bit. In the second case, operation the minuend bit is smaller than subtracand bit. Hence, we take one borrow from the next significant bit. Just as there are half and full adders, there are half and full subtractor as well. Let's discuss half subtractor. A half subtractor is a combination circuit that subtract two bits and produce their difference. It also has an output to specify if one has been borrowed. Let us design a minuend bit as A and subtracted bit as B. So there are two inputs which we can apply to half subtractor. Let's discuss about the truth table of half subtractor. As we seen in previous slide, when we have 0 minus 0 means A minus B, so the difference is 0 and borrow is also 0. Then the next is 0 minus 1. Here the difference is 1 and the borrow is 1, which is taken from the next significant bit. 1 minus 0. Here the difference is 1 and the borrow is 0. 1 minus 1 is difference is 0 and borrow is 0. After defining the problem statement, we need to analyze that the number of inputs and after that what number of output that we expected. Let's get the logical expression with the help of one of the popular method, K-map simplification technique. For a difference and for borrow, we generate two different expressions or logic function for these operations. So K-map is nothing but we plot input and to obtain the specific output. Here in this case, the difference is A B bar plus A bar B. It is also represented with the help of XOR gate. Exclusive OR is nothing but A B bar plus A bar B. So we can also write the difference, the equation of the difference is A XOR B. So it is going to implement it with the help of this XOR gate. Just like that, for the second output, borrow output is there. So here we need to think about the borrow. So as we have implemented this borrow output right from the truth table, this borrow output is as it is implemented and plot K-map for simplification. So this is what the borrow output. Now how you can sketch, how you can draw the logic diagram based on these equations. So this is what the logic diagram. It is somewhat similar with your half adder circuit. Only the difference is that here we use one inverter gate because the borrow is obtained from a inverter B. So we put inverter to the input directly. So A is applied through inverter to your AND gate and B is applied as it is. So we obtain borrow here and here we obtain a difference. Let's see the limitations of half adder, half subtractor in multi-digit subtraction, like more than 2 bits subtraction. We have to subtract 2 bits along with the borrow of the previous digit subtraction. So effectively, such a subtraction required subtraction of 3 bits, because let's consider that the previous output generate a borrow bit. So we need to consider that the previous bit to the next subtraction. This is not possible with half subtraction because there is only 2 input that will given to half subtractor. These are the limitations and which is going to overcome in the next circuit, which is called as full subtractor. A full subtractor is a combination circuit that perform a subtraction between 2 bits, taking into account borrow of a lower significant stage. This circuit has a 3 input and 2 output. The 3 inputs are, let's say, A, B and borrow in from the previous operation. It denoted with minuend, subtractand and a previous borrow respectively. The 2 outputs D and B out represent the difference and the output borrow respectively. Here is the truth table of full subtractor. In that, input is A, B and borrow in. So 2 raised to 3, it gives 8 number of possible combinations, and we are implemented truth table likewise. So the output of this one, when we subtract A minus B, it is 0. In first case, it is 0, 0, 0. Let's say the condition like this. Suppose we consider that these 2 outputs. So 0 minus 0, the difference is 0 and borrow is 0. Again 0 minus 0 means B minus B in, difference is 0 and output is 0. Let's check second condition. In that 0 minus 0, difference is 0 and borrow out is 0. But 0 minus 1, difference is 1 and borrow is 1. So it is going to update it that the previous operation. When we have 0 minus 1, so difference is 1 and the borrow out is 1. So here it is represented like this. Again 1 minus 0, it is what difference is like a previous, it is not going to change, and the borrow is 1, it is likewise. Just like that we will construct a full adder subtraction. This is the truth table available for full subtraction based on the logic, and this is the K-map for the same. In that you will be get the difference and borrow out. This is the logic circuit for this. Here we are implementing this logic circuit with the truth table. Thank you for watching.